Hello there and welcome to a brand new lesson. This is Half Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at pair of angles and their relationship. By the end of this lesson, here are the learning objectives you would be able to achieve. Without much ado, let's quickly look into it. So we'll start by looking at the 5 major angle relationships. Talking of these 5 major angle relationships, we'll be looking at adjacent angles, complementary angles, supplementary angles, the linear pair, and the vertically opposite angles. We will define all of them, and then I will give you a visual representation of them. And then at the latter part of this lesson, we'll solve some questions in relation to them. If we say two angles are adjacent, what do we mean to say? What do we mean? In our previous lessons, we said angles are formed when two lines meet. Now, if you take a look at this angle here, this one. So this, and then there's the white and then the red line. They meet at a point, you see, and that means they form an angle. This is the angle they form. All right, so represented by this arc over here. The same way, the red and then this yellow or golden line has also formed another angle over here. And you realize that this angle and then this angle, they are sharing this common arm over here. See, they have a common arm. Hence, we can say the two angles are neighbors. That gives us what we call adjacent angle. So as a definition, we say adjacent angles share a vertex. So they have the same starting point, and then they have a common arm or a common side. That is what we mean by what? Adjacent angles. Now let's look at complementary angles. So talking of complementary angles, two angles are said to be complementary if they satisfy a certain condition. And that is what we want to verify here. Now, this is a straight line. You see, this, let me say it's a vertical line, and this is a horizontal line. And they meet at a point. They form an L shape. An L shape simply means a 90-degree angle. You see, so it's a right angle. And if we are to take our compass and then measure, you realize that it would be a 90-degree angle, just as you see over here. Now, even though it's 90-degree, we can divide it into two parts. You see, so if I draw another line this way, two angles have been formed. You see, so one of those angles will be this, and then the other will be this. Or I can better say, I can still say we have an alpha and then a beta. These two angles that are formed, it is obvious that if they sum up, they give us the 90 degrees. You see, this red line can be anywhere. It can be here. It can be here. We have two angles, or it can divide it exactly into two to give us 45, 45, or anyhow we want it. So far as adding the two angles together will give us a 90 degrees. Then we say the two angles are what? Complementary. So for the definition, we would say that two angles are said to be complementary if they add up to 90 degrees. See, or if they form a corner. We know a corner looks like a 90 degrees. So if the two angles sum up to 90 degrees, then we say they are complementary. Let's look at the next one, which is supplementary. Now, we know what a straight line is. A straight line spans an angle of 180 degrees. If you have two angles whose sum is 180, then we say they are supplementary. So if I'm to draw another arm or a straight line over here, once again, we said an angle is formed when two lines meet. So in that case, if I'll call this point the vertex of this line, and then this line, and then I'm adding this other line, then we have three lines meeting, of which we have what? Two angles being formed. And what are the angles? So we have this angle and then this other angle. Now, since they form a straight line, we say they are supplementary. Hence, what are supplementary angles? So to define supplementary angle, we simply say two angles that add up to what? 180. And that is it. So two angles whose sum is 180 are supplementary angles, and hence they form a straight line. Now, for illustration purpose, I would do something here. So I'm going to copy this angle and then bring it all the way here. And I'll make two of these. So what we actually have here is this one is just what we took from here. See? But then since there are two angles, so if I'm to call this side the alpha and then this side the beta, this is the alpha, then this is the beta. Now these two remain intact on a straight line. And yes, we have said that they are what? Supplementary, because they sum up to 180 degrees. These two, on the other hand, are not on a straight line. So let me just do it this way. We do know they sum up to 180 degrees. That is the proof from this side. You see? So we do know that alpha and beta from this angles sum up to 180, but they are not on a straight line. You see? So the fact that they are on a straight line gives them a new name. We call them linear pairs. You see? So when we talk of linear pairs, or when we say two angles are linear pair, then first of all, we mean they are adjacent. You see? And they are not only adjacent, but then they also form a straight line. That simply means they are adjacent and are also supplementary. So this alpha and then beta here, they are linear pairs because they form a straight line. They are exactly on a straight line. But though this alpha and then this beta, we know they are supplementary, but they are not linear pairs. Take note of the difference. Linear pairs form a straight line. You see, so not all supplementary angles are linear pairs. That is, this alpha and then this beta here, in their raw state, they belong to two different worlds. But then these two have been aligned such that they have a common arm and they are adjacent. On the other hand, this alpha and this beta, they don't even have a common arm. You see, so we can even say, let me make the arm of this alpha all red, and then let me make that of this all yellow. So as you can see, they have their own set of arms. So this is what we call linear pair. Now, our last type of angles we'll be looking at is what we call the vertically opposite angles. So talking of vertically opposite angles, once again, I would like to remind you that we said angles are formed when two lines do what? Meet. So if we take this gold and then the red line over here, there are four sets of angles that are formed. So let's name these angles. So I would call this one the alpha. So we have alpha, beta, then gamma, and then delta. So there are some properties that these angles that were formed possess. Now, since it is an X, then we can say The angle here that I've named alpha is opposite to what we have here as gamma. And then beta is also opposite to delta. Now, if you are to measure them, let's measure and then see something. So if I'm to measure the angle alpha, as you can see, you would see that is, if we are using the inner calibration, we have about 126. That is for alpha. Now let's come all the way and then measure delta. So using our inner calibration, it also falls on the same what measure. You see, so we can confirm that alpha is equal to delta. In the same way, yours is to try and then measure that of what? Beta and then delta. You realize that they are the same. That is the property opposite angles possess. You see, they are opposite to each other. Anytime you want to think of opposite angle, think of an X. You see, if the two lines form an X, the angles that are opposite each other, we call them vertically opposite angles, and they are equal. So it simply implies that the angle we have as alpha is equal to the angle we have as what? The gamma. Then the angle we have as delta is also equal to the angle we have as beta. That is what we call vertically opposite angle. And mind you, we even have more of what we've already considered here, because angle delta and then alpha are on a straight line, and they are actually having a common arm. So they are even linear pairs, you see. And then we have alpha and then gamma as well being linear pairs. And we have gamma and then beta as well being what? Linear pairs. So when you have any figure, there are so many properties you can see just with one figure. And that is what we'll be doing in our next session. We'll try and then solve some questions using some variables here and there. I do hope this conceptual explanation was helpful. So with all these, let's now solve some examples. So for our first question here, it says two angles are complementary. One is x and the other is what? 2x. You have to find x. Very simple and straightforward. So first of all, look at the property that is mentioned here. You see, so for complementary angles, it simply means when we sum them up, we are supposed to get 90 degrees. So we have to write that. So we start by saying if complementary, then it simply implies that the two angles, that is x and then plus 2x. So the sum of these two angles should be equal to what? 90 degrees. Now it has become an algebra problem. So x plus x gives us a 3x. We have our 3x being equal to what? A 90 degree. Since it is x we want and not 3x, we are going to divide both sides by 3. And with that, we know that this x divides this x to give us 1. And 3 divides 90, give us what? A 30 degrees. Hence, what we have? We have our x being equal to what? The 30 degrees. And that is all. Very, very simple. So most of these problems actually tests your understanding on the properties that you have learned. You see, so do you really know what it means to say two angles are complementary? Do you know what it means for us to say two angles are vertically opposite? Let's try some few more examples. So in our second question here, it says find theta in a linear pair where the angles are theta and then 120. You see, so this is also testing our understanding on whether or not we know what a linear pair is. You see, so we start by saying if the angles are linear pairs, then we know what it means. They are supplementary. So we say if theta and 120 are linear pairs, then it implies they are supplementary. And if they are supplementary, then it also implies that theta plus 120 is equal to what? 180 degrees. So since we want our theta, we are going to make it the subject. So we subtract 120 from 180. And hence our theta becomes what? 60 degrees. As simple as that. One last question. So in this last question we have here, it says two lines cross. Now if one angle is 4x and its vertically opposite angle is 80 degrees, find x. See? So sometimes you can best interpret when you visualize. So I'm coming to visualize and then let one of these lines. So we'll just draw these two lines and then it says if one of the angle is 4x, we're going to put our 4x here, and then the 80 degrees is also going to be here. So these are the two angles that were given in the question. Now the question said they are vertically opposite. So we should know what it means. When we say two of these angles are vertically opposite, it simply implies that the 4x is equal to 80. That is the property of vertically opposite angles. They are equal. If 4x is equal to 80, and then we want an x, all we need to do is to divide both sides by the 4. So this 4 cancels out this 4 once. Then we have this 4 dividing the 80 20 times. So it simply means the x is equal to 20 degrees. And that is all. See? So solving questions under this topic is very, very easy if you know the properties. So with that said, we'll end this lesson here. But as usual, I'll leave you with some exercises so you try on your own just to test your understanding. So here are just 5 questions you can try on your own to test your understanding. They are all very, very simple and then direct. You just need to apply a little algebra. You'll be good to go. Just have beyond numbers. Once again, we will learn maths the easy. If this is your first time on this channel and you do think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, be notified and learn with us as well. See you in our next lesson and do stay safe. Bye for now.